What's up, physics gang? Minutillo here, and I'm going to try again. As you can see, there's many markings of pencil on this paper strip I set up. I'm going to try to show you a demonstration for how you can use some measuring tape, a moving object with a pencil sticking out of the bottom to make markings, and a stopwatch in order to determine something's speed, because speed is literally just distance divided by time. It's how fast something is going. It's how much distance it covers in a certain amount of time. So I have this electric car here who's really not my friend today. It's not working properly, so I'm going to try this like one last time. And what I'm going to do is, as you can see, I have a bunch of markings there, but I know that I'm starting from that spot. And I'm going to measure the length of the pencil markings using this sports measuring tape here, and then divide that by the amount of time it took to get there. So what I'm going to have to do is set this camera up, and I'm going to start this motor and this stopwatch as close to at the same time as possible. And I'm going to do that right now. 3, 2, 1. All right. Ugh, this guy, really don't like him. Anyway, yeah, this thing never works properly. So I've had it. So anyway, that's where I started. Let me follow that line the best I can, because there's another one. I don't want to mess it up. Yeah, it's this further spot here. So this guy links over to there. Okay, so that curved, but still I'm going to do the best I can to measure the length. And I think I got the time when it went off the paper. I hope I got close. Is 9.83 seconds. So actually, I'm going to be a good scientist, and I'm going to write that down so it doesn't get lost. So this took 9.83 seconds. Okay, and now I'm going to measure the length in meters. Not inches. So let's see, that's the starting point. Okay, try to hold that down. If somebody else was here, that would be great. I'm all by myself. I'll line this up because the curve does make a difference. The curved line means that it's actually a longer trip than if it was a straight line. Hey, you know what? I'm gonna get as close as I can. We're not in a government science lab trying to do really important stuff, so I'm gonna get as close as I can without making a really horrible measurement. Close enough for a high school physics class. Okay, looks about right. And again, I'm getting a distance of 2 meters, and then an additional 75 centimeters. So that's 2.75 meters. Okay, that's what we need. We got it. So we have the time, t equals 9.83 seconds, and the distance is 2.75 meters. If you don't believe me, again, tried the best I could, but see, 2 meters, and then about 75. And 75 centimeters, 0.75 meters. Okay, there we go. Now, time to do the math. See you in another place where we're doing the math.